Alright, in this video we're going to talk about the camera in Blender. We're going to learn the basics and how we can use them properly to get the best results. We're going to go over viewport visuals and composition guides, depth of field, and most importantly different focal lengths and how they would affect our scene. So this is my scene right here. I have a background here. This is my subject and this is my camera. First thing I'm going to do is remove all the distractions up here to get the closest result to the actual render. So first of all, I'm going to press N to hide this panel here. So that's that. And then I'm going to press T to get rid of these tools. And for these, and if you have any other gizmos like the move gizmo enabled, this is the gizmo, show gizmo button. So you can disable all that with this. And now for the 3D cursor, the what was it called? The origin point and the outline, I'm going to go here. I'm not gonna disable these altogether because I'm gonna need them later for the composition guides. But I can just disable the 3D cursor, the origin, the point in the middle, and outline selected, so I don't get that line there. Now I'm going to go to I'm going to select my camera, go to my camera settings here, and under viewport display, this setting called passbar 2. By default it's set to 0.5, so the outside area, the areas outside of what your camera is actually seeing and would render is just blacked out a little. So if it's set to 0, you can see everything, just this border here showing what the camera is actually seeing. And if I increase this all the way to 1, everything would be blacked out and I can just see whatever my camera is seeing, so no distractions. So right now, if I just press render, this is what I'm going to get. Okay. So now I'm going to go to my composition guides under the viewport display. Let me go to my solid view so we can see the lines better. So we have 3 kinds of composition guides here. The center, the golden, which would be the golden ratio, and triangles, and harmony. Right now we're just going to use the thirds because I'm going to change my focal length up here later on, and I'm going to align the nose with this line here. Okay, so I'm gonna just leave that on. You can have multiple guidelines on, but I'm just gonna use the thirds. Now for our depth of field here, this one here. So I'm going to go to my render view again, and if I enable that, by default it's set to 10 meters. So let me go to my viewport display and show the limits. So this line here, this is actually my focus distance. Right now it's set at 10 meters. And if you notice here, my camera is selected and it's at -5 meters, 5.6. So if I set this to somewhere around 5, that line is going to jump here, and now my object, the monkey here, is in focus. Okay, if I change this manually, now it's out of focus, so it's blurry right now. The thing about using this distance is that if it's a constant distance in front of the camera, so if I select my camera and I move my camera, this is going to move with it, and now my object is still out of focus. So I'm going to undo that, and here we can change a focus object. So I'm going to click here and select this Suzanne object as my focus object, and now no matter where I move my camera, it would stay there. So you can see the line here in the middle. But the problem with this is that it would be set to the origin point of my object. So right now the origin point is here in the middle, and that would be my focus distance would be set to this middle. So I want the sharpest to be here, the face. Okay. So there's another problem with this, and if I have multiple objects in my scene and my camera is moving, I can't change this. I can't just switch this in the middle of the movement of the camera to another object. So how can we fix that? We're going to add an empty here. So I'm going to add a plane axis and move it in front. So to the face right here. And now I'm going to set that empty as my focus object. So right now the focus is here in the front of the object, the face that I actually want to be the sharpest. And if my camera moves and I want the focus object, the focus distance, the focus of my camera to move, I can just grab this empty and move it with the camera. Okay, so now if I put it here, it's blurry. If I move it here, it's still blurry, and I can change the sharpness and the focus of my camera just by moving this empty. Okay, so that's that, and let's go over the most important part of this video, the focal length. So we have 3 different types of cameras in Blender. Right now, by default, it's set to perspective. We have orthographic, which looks something like this. Let me disable the depth of field so we can see that better. And in orthographic view, only our depth of field, only our view angle is important. So it doesn't matter where I put my camera. The camera is right now here near the object, and I can move it way back and nothing happens here. There's no difference. In perspective, the further our object is from the camera, the smaller it would look. But here, it doesn't matter where the camera is. So you can just change this scale here to change this angle, this view angle of the camera. But other than that, it doesn't matter where you put your camera. So I'm going to undo that. And the other type of camera that we have here is panoramic. It has some types of its own, so it has some fisheye and mirror ball, and I don't think you would ever use any of these. These all look kind of distorted and weird, so I'm gonna just go back to the perspective and talk about these focal lengths. So by default, this focal length is set to 50 millimeters. Right now, I'm going to show you some extreme ends of this focal length. So I'm going to go super wide, 16 millimeters. And to be able to frame my subject here in the entire viewport, I have to just move my camera closer. And I'm going to align the nose with that composition guideline that we enabled earlier. I'm going to just hide my plane axis. I'm gonna delete it. Okay, so, and let me go and disable this limit. So right now I'm at 16 millimeters and I had to move my camera way close to my subject. I'm going to keyframe that and keyframe the location of my camera. And now I'm going to increase it way high, so telephoto 200 millimeters. I'm sorry, I have to first move this and 120 frames. So I'm at 24 frames per second. It would give me 5 seconds of video. Now I'm going to increase this to 200 and keyframe that again. And now I have to move my camera back all the way here so I can just align the nose with that line again. And I'm going to keyframe the location. So now let's see how it would affect our scene. I'm going to hit play, and you can see the difference that it would make. Okay, so the reason that it's moving in and out like that is because it's not rendered, so I'm going to show you the final render of this. It goes way more smoothly, so you can see the difference that the different focal lengths would make. Okay, so let's go over those. Let's go over those. And this is my 16 millimeter, and let's look at that side by side with the 200. So there are quite a few differences here. First of all, the higher your focal length, the more compression your scene would have. Okay, so here you can see this is my subject and this is my background. So the distance is like this. But right now here, because the lens is too wide and my camera is way too close to my subject, the background looks further back, and here the background looks closer to my subject. So the higher your focal length, the more compression you would have. And you can see that in the also in the face. So here the face looks round, it looks spherical. Okay, here I can see everything. The face looks flat. I can't properly see the forehead here or the ears. And now here I have them all completely in my view. Okay, so these are two extreme examples. You probably rarely would use any of these, especially if you're working with something like a face, because this looks distorted and this looks unflattering, it looks flat. Okay, let me show you another example of these focal lengths with a car. So I have a Porsche here, and this is 16 millimeters to 135 millimeters. So you can see how it can change the look of the car. Okay, and you can see the compression between the background and the foreground. And let's go to the images again. So this is 16 millimeters and the camera is close, and this is 135 millimeters. So here I can't see the interior of the car, I can't see the seats, I can't see just the elongated, distorted. If you look at the... Okay, my cat is going crazy again. Sorry about that. Here. Okay, sorry about that. What was I saying? Here you can see the length of the car. It's kind of elongated and distorted. If you look at the mirror here, you can't see the rear spoiler or inside the car. Okay, but here I can see everything because the car looks flat. I can see the inside, the seats, and the entire car is in my view. So probably for a car you wouldn't choose any of those. You would go somewhere in the middle like this, for example. So you have the depth of your scene. It doesn't look flat and it doesn't look distorted either. Okay, so again, these are extreme examples to show how different focal lengths would affect our scene. So if I have, for example, I'm rendering a nature scene, there are trees and everything, and I want to have the entire environment in my viewport, I would probably use a wider lens and not put it close to any of those objects because they would probably look distorted. And if you're, for example, you have a face, a human subject, something like that, you would probably go something around 50 to 85 millimeters. Okay, so just know how these different focal lengths would affect your scene and choose them properly and consciously. So this is it for today's video. If you liked it, please leave a like down below. In the next video, we're going to talk about some camera rigs and constraints that you can use to better utilize your camera in your scene. And subscribe if you want to see that and more. I'll see you in the next video.